decrease their resistance as the ambient light in the room increases. As I decrease the light in the room, the resistance will increase. So if we hook this up in a voltage divider circuit with a fixed resistor, we can essentially feed into the Arduino a voltage that varies with light in the room. So let's hook that up using this schematic. Here's our assembled circuit. Just like in the schematic, we have a photoresistor connected between 5 volts and a 10K resistor. The 10K resistor then goes to ground, and at the junction between the two of them, we take a wire out and go to analog input 0 on the Arduino. This is just like our voltage divider setup that we worked on in the last episode. Now let's program this to show us the values from the photoresistor as we change the light in the room. Note that you can change the position of the photoresistor and the fixed resistor, and the values in the computer will inverse. Let's write a quick program that will show us the value of this sensor. So first we'll need to define our input pins. We'll call it sense pin. That's going to be equal to analog input on pin 0. Now we always want to do our setup function. And in here we don't need to define it as an input pin because it's set to that as default. We can define the analog reference as default. That's because we're going from 0 to 5 volts. But again, this line isn't necessary. It will do this by default. But I'll just put it in here for complete coverage. And we'll want to print this to the screen, so let's set up our serial connection like we did last time. And the 9600 just means the speed at which we're communicating with the computer. 9600 baud is a pretty common value that you use. Alright, and in our loop, all we're going to do is read the sensor and then print it to the screen. So serial.println, just like last time, analog read, and the sensor pin. Sense pin. Make sure we close our parentheses. And we don't want it to spit out values constantly, so we'll just put a delay in there of a ½ second. That should be good. Alright, let's see how this works out. So we can see that in ambient light we're getting a value of about 950. And as I put my hand over the sensor, we can see that drops down. If I cover it completely, we go down to about 750-ish, 770. Okay, great. But that's only giving us a range of 200 out of a potential range of 1024. Why is that? Well, it's partially because of the resistors that we've chosen and the inherent fact that you're going to lose some values by using a voltage divider, which is fine. We don't need the full 1024 of resolution. You can overcome this by setting up an op-amp and doing a few other things, but it's not really that important to us. If we want, we can try to change the resistor to a 1K resistor and see how that changes it. Now we've got a 1K resistor in the circuit instead of a 10K resistor, and we can say let's change the values. Now ambient light is closer to around 570, and if I put my hand over it, it drops down to about 200. So that range is a little bit better, not by much, and you can keep messing with the resistor values until you get a value where you're happy. But in reality, this amount of range is fine for what we want to do. We just saw that a value of around 900 is ambient lighting in the room, so let's make a simple night light now. If the value goes below 800, we'll turn on an LED that will illuminate the room. So all I've done here is add an LED to our circuit with our 150 ohm resistor, same as we used last time, and I've hooked it into pin 9 on the Arduino. So let's go program that. Alright, the first thing we'll have to do is to add our LED pin here. And that's going to be pin 9. Next up, we have to set that pin as an output because it defaults to an input. So let's make the LED an output. And we can get rid of the serial communication. We're not going to use that anymore. Okay, down in our loop, let's start by getting the value from the sensor and saving it to a variable. So we'll make a new variable called val. Pretty standard name. Do an analog read of the sense pin. We don't need this one. We don't need either of these anymore, right? And then if the value is less than 800, we'll do something. So we'll use an if statement, which checks the value. So if the value is less than 800, we will do a digital write to the LED pin and turn it on. Otherwise, if it's greater than 800, let's make sure we turn it off. Digital write, LED pin, low, which will turn it off. And that's it. So let's see how this works. Okay, great. We put our hand over it and the LED turns on just like we want it to. When it gets too dark in the room, we'll have a nightlight now. Now you don't have to be afraid of monsters in your closet.